Do you have the time to listen to me whine about nothing and
Alright, welcome to lesson 10.3, circumference and area of a circle. Now, because a circle is not a polygon, we have a slightly different concept with the idea of perimeter. Perimeter of a polygon, you add up all the lengths of the sides all the way around. Well, circumference is a little bit different. I'm going to define that in just a little bit. Area is pretty much the same. It's going to be the space inside. So first things first, let's define a circle. A circle is a set of all points in a plane that are the same distance from a fixed point known as the center. There's my center, there's my distance all the way around every point that's that distance around. Now I didn't draw that freehand, although you can see I kind of drew it freehand here, but that's the idea of a circle. This is the center. The distance between the center and any point on the circle is the radius. The distance between across the circle, all the way across the circle, through the center is the diameter. So if I do something like this, if I can draw it halfway straight, I'll try it again. There we go. That's the diameter. D for diameter and R for radius there. C stands for the center. Alright, now, those ideas you've had before. I'm sure you've had those before. The idea of circumference you've probably had before. The circumference is kind of like the perimeter of a circle. It's all the way around. But because it doesn't have sides, it's very difficult to evaluate from scratch. In fact, it takes the idea of a limit, something that you'll study in calculus. But just know that the circumference, when they ask for the circumference, they want the distance around. What we need is a formula. And that formula comes from the fact that the ratio of the circumference all the way around and the diameter is always the same. If you have a small circle, you have a big circle. You measure the distance around with like a tape measure, you measure the distance across, and you take the ratio of the circumference and the diameter, you always get a number that's extremely close to 3.14, which we call pi. Pi is approximately 3.14. We talked about it just a little bit a unit or so ago when we were talking about irrational numbers. Pi is an irrational number. The circumference of the circle, here's your formula right here. The circumference of the circle is pi times the diameter. So we'll have to approximate it on our calculator. We'll probably just stick with 3.14 and then we'll multiply it times the length of this diameter. Or since the diameter is just twice a radius, you can think of this as your formula. Circumference equals 2 pi r because 2r is the diameter. Either one of those will work. It kind of just depends on which one you want to use, what's given to you. In this first example, the diameter of the circle is given to be 28 feet. So I'm going to use this formula right here. We're going to find the circumference to the nearest foot. So my circumference is going to be pi, or about 3.14, times my diameter here, which is given to be 28. So it's about this time that I find my calculator. There it is. And I multiply on my calculator 3.14 times 28. And I get 87.92. Since they want it to the nearest foot, I'm going to write it as 88 feet. Now notice it's not 88 square feet, it's not area, it's like perimeter, it's a linear distance, it's one-dimensional, so it's just in feet or just in meters or just in centimeters or just in inches, depending on the units. The second example is a little different. Here I give you the circumference. It says the circumference of a circle is 186 centimeters. Find the radius of the circle to the nearest centimeter. So I'm going to use this formula this time. I'm going to write C equals 2 pi r, but I'm going to plug this in for C and 3.14 in for pi, and then I'll solve for r. So I get 186 equals 2 times 3.14 times r. Now 2 times 3.14 is 6.28 times r. So I'm going to divide both sides by 6.28. Hopefully you can still see this. I didn't go too low on the screen there. And if I divide, and again it's time to grab my calculator. Those are going to cancel. I'm going to get r equals, so I get my calculator. I take 186. I divide it by 6.28. And this is to the nearest centimeter here. So I get, well, let me clear that out. That's wrong. You got to clear it out from the problem before. 186 divided by 6.28, and I get 29.61. And again, since I'm rounding to the nearest whole number, to the nearest centimeter, this would round up to 30 centimeters, and that would be my answer. Hopefully you can read that. I'll put that up here just in case, 30 centimeters. And that's how we do circumference problems. Okay, the area of a circle, and this formula also is derived using the idea of a limit and the area of regular polygons, is given to be area equals pi times r squared. Now there's not another formula like we had with circumference where one's in terms of radius, one's in terms of diameter. We're just going to use this one right here. Area equals pi r squared. There's a really bad joke. Pi r squared, pi r not squared, pi r round. But you know, if that helps you to remember it, that's fine. We're defining the area of each circle. Now, I am going to use 3.14 and I'm going to round my answer to the nearest square unit here. So for the first one, I have the diameter is 14 inches. So I'm going to divide by 2 and I get the radius to be 7 inches. So my formula, A equals 3.14 times 7 squared, which is 3.14 times 49. Remember, you do the exponent first. So I grab my calculator, 3.14 times 49, and I get 153.8, or approximately 154. This is in inches, so my area is in square inches. Now in part B here, I already have the radius, so I'm going to just substitute right in. Area equals 3.14 times 12 to the second power. 3.14 times 144. And so again with my calculator, if you want to do this on scratch paper for the practice, that's fine. 452.16, or 452 to the nearest whole unit here, square unit, square centimeters. So you're rounding it to the nearest one. Alright, and the next example here, they give you the area, they're asking for the radius. In fact, that's for all three of these, where they give you an area and then they ask for a particular measure. Okay, so in this case, the area, remember, is right here, area equals pi r squared. So 250 gets plugged in for A equals pi, or 3.14 times my radius squared. First thing I'm going to do is I'm going to divide by 3.14. And I get r to the second power is equal to, well, 250 divided by 3.14, I get 79.62, approximately 79.62. I have to take the square root of this. R equals the square root of that, so I'm going to take the square root of this value. So let me clear this out. I hit the square root of 79.62 and I get 8.9, which I'm going to round to the nearest inch, or 9 inches. That would be my radius. Very similar on this next couple of examples. Here's the area, they're asking for the radius. Here's the area, they're asking for the diameter. Not a whole lot of different steps. So I'm going to do this one just like I did up here. I'm going to plug into this formula. 1,567 equals pi, or 3.14 times the radius squared. I'm going to divide both sides by 3.14, and 1,567 divided by 3.14, I get 499.04. So I have r squared equals 499.04. I'm going to take the square root of that to find r. So when we clear that out, square root of 499.04, and I get 22.33, or in this case, I'm rounding it to the nearest whole amount, 22, and this is in inches. That's the radius. Now I'm going to do almost the same exact thing on part B here, with one extra step at the end. So I'm going to take and plug into here, 197 equals 3.14 times r squared. So again, clear out 197 divided by 3.14, and I get 62.74. I get r squared equals 62.74. Always take it out a couple of decimal places, because if you're rounding to the nearest whole number and you round at this step to the nearest whole number and then do it again, that's called intermediate rounding, and you'll end up with a less accurate answer. You could be off by one. So take it out a couple decimal places at this step, but when you take the square root of this, which is next, round it to the nearest whole number, so the square root of 62.74 gives me 7.92, which is approximately 8, and this is in centimeters, but that's not my answer. They want the diameter. The diameter is twice the radius, so that's going to be 16 centimeters, and that's my answer right there. Now this last example, I've got another drawing there of a circle, and I'm asking you to find the area and the circumference of the circle. So we're doing 2 steps here. I'm going to have 2 answers. We're going to round to the nearest whole number. So first things first, since I have the radius, I think I'll find circumference first. That's 2 pi r, so that's 2 times 3.14 times 24. So again, 6.28, that's this part, times 24, and to the nearest whole number, this is going to round up to 151, and this is in feet. Okay, not square feet, that's circumference. The area is 3.14 times my radius of 24, and that gets squared. So you square that first. 3.14 times, I think it's 576, but let me make sure. Yeah, 576, and then I'm going to multiply the 576 times 3.14, and round to the nearest whole number. This rounds up to 1,809. So the area is approximately 1,809 inches here, or excuse me, feet here, so this is going to be square feet here. And that's the circumference and the area both. It doesn't go as deep into the idea of a circle as you can study in geometry. There's a lot of interesting stuff about the idea of a circle, but it's enough to get you going on this. And remember, practice, practice, practice.